Hello everyone, we are Remila Joyce Mary, Darshini and Surya. We have chosen a company which electrified the online world with its web's best search engine, that is Google. Let us see the backup and storage solution adapted by the company Google.
Now let us see the introduction for Google. As we all know that Google is a multinational technology company that specializes in internet related services and products. It was founded in 1998 by Larry Page and Sergey Brin while they were the PhD student at Stanford University. Google's mission is to organize the world's information and make it universally accessible and useful. Google is the best known for its search engine, which has become the most widely used search tool globally. It provides users with relevant search results based on their queries and employs sophisticated algorithm to deliver accurate and timely information. In addition to search, Google offers a wide range of services: Gmail, Google Drives, and Google Docs, Sheets, Slides, Google Chromes, and Google Maps, Google Ads, and etc. The company also has a significant presence in the field of artificial intelligence and machine learning, with various applications and research initiatives. Google has adapted multiple storage and backup solutions. Let us see one by one.
Now let us see the storage devices that Google use. Google has built its infrastructure using various storage devices and technologies. While the exact details of the internal storage was not publicly disclosed, but they have shared some information about the storage devices they use. First, the hard disk drives. Hard disk is very much cost effective and it is used for storing large amount of data. So Google uses the traditional spinning hard disk for storing data. And then second one is solid state drives. So solid state drives has a faster read write speed when compared to HDD. So this solid state drives is used for improving the performance for the latency sensitive workloads. So latency sensitive workload means the application which is very much sensitive to time. And then third one is custom storage solutions. There are 5 custom storage solutions: Google File System, Colossus, Google Cloud Bigtable, Google Cloud Spanner, and Google Cloud Firestore. First two were the storage techniques that are adapted by the Google for storing their data, and then the last 3 were the databases that is used for storing the company's data, users data. So these are all about the storage devices that Google uses.
We explained the backup devices implemented by Google. Google employs various backup techniques to ensure the safety and availability of data across its services and infrastructure. First technique implemented is redundant data replication. Google replicates data across multiple data centers and storage nodes. It helps to protect against hardware failures and network issues. Second technique implemented is incremental backup. We all know about incremental backup. This technique minimizes backup time and reduces the space required for backups. The third technique implemented is snapshot based backups. In this technique, Google takes snapshots every now and then, either automatically or manually, to ensure data integrity and facilitate quick recovery. Next, let's see about the distributed backup system. In this technique, they distribute the backup workload across multiple servers and clusters. Finally, data deduplication is utilized to eliminate the redundant data during backup processes. These are some of the techniques implemented by Google to ensure the safety and availability of data.
Now let us see the storage techniques implemented by Google. So the first solution is Google File System. Google has initially adapted the storage technique known as a Google File System. Google File System is actually a distributed file system. Distributed file system means the file system that is distributed across multiple storage devices in a network. So this Google file system is more scalable and reliable. And then let us consider the Google's search engine, how enormous amount of data is produced from that. So all these data will get stored in this Google file system. So Google file system is used for storing enormous amount of data. And then this Google file system is used for storing the file data as well. So there are 3 components of this Google file system. First, the GFS client, the GFS master server, and GFS chunk server. So GFS client is actually the application where the request is sent. So the GFS client sends the request of the file, and then GFS master coordinates the entire Google file system, and then the GFS chunk server. So GFS chunk server is actually a storage node where all the data get stored. So this GFS chunk server will store the data in the form of chunks, that is 64 MB in size, and each file is in the form of Linux files. And then each chunk server will have 2 to 3 replicas. In case if the data fails, if the data lost in one chunk server, we can restore them from its replicas. Now let us see the workflow of the Google file system. First, the GFS client will send the file request to the GFS master. So this GFS master contains the file and the chunk table. So this maps the file name with the chunk server index, and it returns the file name with the chunk server index to the GFS client, and then this GFS client will access their data will access the GFS chunk server with the help of the chunk server index and get its required file. So this is the workflow of the Google file system. Now let us see the benefits of the Google file system. So Google file system, so there will be always the data availability. So in case if the data is lost in one chunk server, we can restore it from the other replicas. And then high throughput, all the storage nodes are working concurrently, so there will be always high throughputs. And then this Google file system is more reliable. So now let us see the problems associated with it. First, the scalability problem. Although the Google file system is very much scalable, it is not enough for storing the growing data. So it is not scalable. So there will be the scalability problem. And then the single point of failure. If the GFS master server fails, then we cannot able to. Then the system would face the downtime, and we cannot able to access the data. And then data consistency problem. So the different user data, different version of the same data, so there will be the data consistency problem. And then limited random write performance. In the Google file system, there will be only sequential write performance, so there will be not random write performance. And then complex management, it is very much complex to set up and manage. So these are all the problems associated with this storage technique. And then who has this problem? So the Google company itself faced this problem because they are not able to store the large amount of data. So the company itself faced this problem. And then why Google needs to solve this problem? So because of the data growth, performance, reliability and availability, scalability, innovation and future services, the Google needs to solve this problem. So Google developed a next storage technique. So let us see this in the next slides. So these are all about the Google file system.
And the next technique is Colossus. Colossus is the current storage technique adapted by the Google. Colossus refers to the Google's internal distributed file system. Google's transition to Colossus from the earlier Google file system primarily addresses the challenges posed by increasing data volumes and the need for greater scalability and reliability. Colossus offers improved performance, scalability, and durability compared to the GFS. It is designed to handle the massive amount of data generated by Google services and providers. Enhanced fault tolerance, faster data access, and more efficient storage utilization. The transition to Colossus enables Google to better support its ever-growing user base and deliver a more robust and reliable storage infrastructure. And this is the architecture of Colossus Google Cloud Storage. Problems associated with that storage technique: complexity, vendor lock-in, limited accessibility, cost. Who has this problem? Colossus is the proprietary file system developed and used by Google. This can create vendor lock-in, making it difficult for user or organizations to migrate their data and applications to other storage platforms. Benefits of this technique: performance, reliability and availability, scalability, flexibility and customizability.
Now let's see about the blueprint of Google's data center. In one day, people search for about 5.6 billion queries. So now imagine how big the Google's data center should be to respond to the people's queries. Google's data center has 6 levels of security to prevent unauthorized access. The people uses about 260 million watts of electricity, which is 0.01 of the world's energy. A large amount of water is needed to support the cooling system in water towers. Some of the data centers are near lakes and rivers. Google CEO Sundar Pichai said that the company is investing $13 plus billion in new campuses, so they will create 10,000 jobs in constructions to maintain the data center. Now let's see how many data centers are present worldwide. There are 8 data centers in US, 1 in South America, 4 in Europe and 2 in Asia. So there are 16 data centers in total.
Let us see about cost perspective. There is no cost perspective for Google File Systems and Colossus. Only Google Cloud Storage has cost perspective. Let us see one by one. The first thing is storage capacity. Google offers different storage tiers and plans with a varying storage capacity. Generally, as the storage capacity increases, the cost tends to increases probably. And the next thing is service level agreements, SLAs, and defines the granted level of services, availability and performance provided by Google. Services with a higher SLAs such as a lower downtime or faster data retrieval may come at a higher cost compared to services with lower SLA.
Storage class and access frequency. Google offers different storage solutions under different storage classes like standard, nearline, cold line, and archive. Standard is used for frequently accessed data, and other threes are used for storing infrequently accessed data. So the storage classes with faster access time and higher availability will be more cost. So in this case, standard will be more cost than when compared to other three. And then backup frequency and retention period. So the backup frequency and retention period also impact the overall cost. If we backup more frequently and the retention period of the data is more, then it will be more costlier. And if we backup less frequently and the retention period of the data will also be less, then the cost will also be less.
Additional services and features. Google provides additional services and features that may have associated costs. For example, advanced data encryption, data transfer, data egress charges, and data lifecycle management tools may incur additional expenses. Usage and subscription plans. Google offers various pricing models, including pay as you go, monthly subscriptions, and enterprise agreements. The specific plan you choose and the duration of your commitment can affect the overall cost. It's worth mentioning that Google's pricing can be very complex and may vary for different regions and customer types, such as individuals, business, and enterprise.
Now let us see about security perspective. Data encryption. Google employs encryption to protect data at rest and in transit. This includes using encryption algorithm to secure data sorted on the storage devices and encrypting data during transmissions over networks. Google's encryption mechanism aim to safeguard data conveniently and integrity. And redundancy and replications. Google implements redundant storage and replication technique to ensure data durability and availability. Multiple copies of data are sorted across different geographic locations, reducing the risk of data loss and enhancing reliance against hardware failures or other issues.
Vulnerability management. Google manages vulnerability by using various methods like regular security audits, penetration testing, and vulnerability scanning. So these methods are used to prevent the security risk associated with the data. Access control and authentication. Google uses the access control mechanisms to prevent the unauthorized access of data. They use various methods like password, multi-factor authentication, and cryptographic keys to ensure the authentication of the user's data.
Disaster recovery and business continuity. A company like Google receives many requests in a particular day. We people, no matter what, need the response for the request as soon as we type the query. So, Google should not take much time for recovering when an incident occurs. Google incorporates robust disaster recovery and business continuity practices to ensure data resilience and uninterrupted service availability. This includes backup strategies, redundant infrastructure, and failover mechanisms to handle unexpected events and minimize downtime. Physical security. As I said earlier, Google uses 6 levels of security to prevent unauthorized access. So, Google's data center and storage facilities are highly secure with strict physical access controls in places. These measures include biometric authentication, video surveillance, security guards, and other physical security protocols to prevent unauthorized entry of or tampering.
Let's see about other remarks. Scalability. Google's storage and backup solutions are designed to be highly scalable, allowing customers to easily increases or decreases their storage capacity as their need evolves. This scalability is particularly valuable for business with fluctuating storage required or those that experience rapid growth. And the next thing is integrations with the other Google services. Google storage and backup solutions integrate seamless with the other Google services such as Google Drives, Google Photos, and Gmail. These integrations allows users to easily access and share data sorted on the Google's infrastructures across multiple platforms.
Developer friendly. Google's storage and backup solutions are developer friendly because they have extensive APIs and software development tools. Advanced analytics and machine learning capabilities. Google Cloud Storage will have the analytics tools to analyze the usage pattern of the data, and then the Google's Cloud Backup have the incorporates the machine learning capabilities to identify and prevent the data loss due to the accidental purpose.
Let's see multi-cloud support. Google Storage and Backup Solutions support multi-cloud environments, allowing customers to integrate and manage data across multiple cloud platforms. This support enables users to leverage the strengths of different cloud providers while avoiding vendor in-lock. It's important to note that these challenges are not unique to Google and are typical considerations when using any cloud storage or backup services.
Conclusion. In conclusion, Google is the multinational technology company that has a profound impact on the internet and the way of access and interact with information. Google's mission to organize the world's information and make it universally accessible and useful has driven its innovations and expansions into various domains. It has revolutionized the way we search for information, communicate, collaborate, store data, and navigate the world around us. Overall, Google's products and services have become integral part of our daily lives, employing individuals, business, and organizations to connect, create, and access information in a fast and efficient and in meaningful way. Thank you.